just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid Galaxy, we see it all. Technological marvel standing tall. Liquid Galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night, collaborate in a...
So let's start this. Victor, hello.
Hello. How is everyone? Nice to see you.
Nice. We are trying something different today. The audio seems to be good. Just we need some feedback from our colleagues in YouTube and the Discord stage of the Liquid Galaxy community. So please, if you're listening to us in whatever platform, say something. Say you're listening to us good or bad. Victor, how are you?
Very well. Very excited to share, some new things that I've been preparing for our future and current students, of course, that are going to be interested in doing web technologies in the Liquid Galaxy. So very excited to tell you a little bit on, what's the best practices if you want to use web technologies directly on the Liquid Galaxy as part of your project. And yeah, hopefully today everyone will learn something, including myself.
Okay, let's make the same question again. Devanjan, are you listening to our sound? We need to have some check from you. I'm checking with this ear. It seems to be good. Audio is good, says Devanjan. Thank you, Devanjan.
Yeah, it's good. All the best for the session.
Let's
Thank you,
hope
Devanjan.
this continues this way. Yes, audible. What means audible, Dev? Mothan, it's good or it's just depends size is perfectly clear. Amazing.
Perfectly clear. So imagine it's better than good. It's better than good.
Clear.
Yeah, it's better than good.
Okay, so
Awesome.
Victor, thank you very much for joining us today. You are a very, I would say, old mentor at the Liquid Galaxy project. So thank you very much for having time. Also,
I am old myself, and I have been collaborating for very long. So both things, I am old in both senses today.
Also, one question: if you want to share, you are actually not in US, not in Spain. Where are you now?
Not in US, not in Spain. I am in Seoul, South Korea. So annyeonghaseyo for those who speak Korean. But yeah, connecting from quite far away. But yeah, you know that in order to collaborate with the Liquid Galaxy, I will always find the time, no matter where I am in the world.
Oh, that's pretty nice of you, and we know well. Thank you very much.
Of course, you know me.
So today is the very first streaming we are doing this year as in the series we call Training the Community. So you're gonna...
No pressure, I'm first.
No pressure. Yeah, it's not your first talk. So what is the point about today? Web technologies?
So we're going to kind of review, right? We're going to, I have to confess, speak very little about the Liquid Galaxy setup itself, because the beauty of the web technologies is that you need to know actually very little about the Liquid Galaxy in order to run a web simulation on top of it. So what I'm going to show you is how, even knowing very little about the Liquid Galaxy, you can choose to pick web technologies as your way to create your projects on the Liquid Galaxy and still enjoy that massive panoramic view that the Liquid Galaxy offers. And I'm going to show you three kind of main things: how to create backends that are Liquid Galaxy ready, how to create frontends that use both 2D and 3D, and of course, we're going to talk on how to make very performant, almost gaming-like simulations that you can synchronize across 3, 5, 7 or more screens in Liquid Galaxy setup. So I am quite excited. And not only that, Andreu, I have a surprise for everyone at the end of the stream. And is that there is I don't like to. You know that I don't like. I love talking, but I love trash talking. And at the end of it, if I don't show you the code, it is trash talking. So not only I'm gonna give you this conference, but I have prepared a demo both in 2D and 3D, and I'm gonna be releasing it open source at the end of this talk. So all of you can fork it and get started. Try it by yourself.
No pain, no gain. So
That's
risky
how it
business.
works.
So it's you noted a very important point is that the Liquid Galaxy system, the project, is not always focused 100% on the Google Earth visualization, but we have the possibility of launching a canvas on every screen with a Chromium, so you can paint whatever you can paint on a canvas with whatever technology. It's fantastic, and your presentation today is about this, and it's very important because people sometimes see us only as the Google Earth showing at contents. That's what we like because Liquid Galaxy is about this. But we also have this other immense, very big.
Okay, so I have a confession to make, Andreu, and is that I have been collaborating with the Liquid Galaxy now for many, many years. And I'm going to tell you how many projects I have done that show Earth at all in the Liquid Galaxy. And it's exactly zero.
Because it's
zero project.
It's your expertise. Your expertise is our web.
That's true. But basically, I've shown, a space, I've shown Mars, I've shown robots, I've shown games, but I have never shown Google Earth. Any of my students and any of the projects for many years, nothing on the piece.
That's good. So, thank you again very much, Victor. I'm gonna pass you the word, and just for the colleagues that are in the Discord, 11 people. This is you're gonna see the Meet screen, and the people that it's on the YouTube are gonna see a little bit more better screen that is based on the OBS with the face of Victor and his slides. So thank you, Victor, and I'm going out of the Meet, but I will be here all the time of the competition. Okay, thank you.
Awesome.
Stage
Fantastic.
is yours.
Fantastic. So thank you very much, Andreu, for the invitation. Thank you to the Liquid Galaxy project and to the Google Summer of Code for having me, not only today, but for many years as a mentor. And to many of the students that have been with me, thank you for tolerating me as a mentor. I'm a very particular mentor, as if your project gets selected and you get to work with me, you will see that working with me sometimes is challenging, but hopefully, the students are happy with the result, and Google has been happy with every result that we have ever presented at the end of this project. So I'm very proud to be a streaming #1 of this kind of preparation for Google Summer of Code 2026. As I mentioned before, I'm a Google developer expert in web technologies, and my expertise in the Liquid Galaxy world has been always the weird projects, right? The projects that do not conform to what is typical. It's not only Google Earth, as Andreu mentioned, but my focus usually is what happens inside the browser, and this can be very different, right? I have done projects that go from, again, Pac-Man Galaxy, which is one of the examples that I will put today, things like a space chess, which was one of a very exciting project where we launched something to space even to play chess against, and I'm going to mention that as well. But I have done many others, like the last one, Devanjan is here today as an audience member. So we did a simulation with the Liquid Galaxy and Gazebo. In that case, web technologies were being used as well in a different way that I will be talking today, because what happened there is a video streaming from Gazebo and the different screens. So a little bit different on what I will be showing today. But the important thing to understand and the important thing to know is that piece of the Liquid Galaxy is definitely not only Google Earth. And now that Andreu is not listening, I will tell you, some of the most interesting projects usually are not related with Google Earth. Despite that, obviously Google Earth is still, I'm sorry, Andreu. I know he will unmute for that one. Okay, so kidding aside, what are we covering today? So I'm going to be covering the web technologies that can be used and are in use in many Liquid Galaxy projects. I'm going to be going as well through the kind of classification of how do I create a very, very simple but very, very efficient and performant backend with Node.js, Sprex, and Socket.io. Here, obviously, we're using HTTP servers, we're using an HTTP framework as well, and Socket.io is a wrapper for a very important API that came with HTML5, which is WebSockets, and revolutionize real-time inside the browser. So we're going to definitely be using WebSockets as well, but we are wrapping it with Socket.io because it has a number of advantages that I want to share with you as part of this. So on the front-end side, we're going to once more talk about HTML5. HTML5 canvas allow us to draw with almost native and gaming-like performance, rasterized graphics that can have a 2D or a 3D context directly on the browser. And we're going to be talking as well very little about Three.js, which is what I recommend you to use if you want to do things or relatively complex things in 3D on the Liquid Galaxy. There's going to be a lot of code in this presentation, especially on the second half. And there's going to be also a live demo because I like Risk quite a bit. So let's go and let's get started. First of all, why you should use web technologies instead of anything else on that piece. And obviously, I love web. I am a Google developer expert in web technologies. So I'm going to try to sell you on my area of expertise. And hopefully, as I mentioned before, you can be one of my students, one of my mentees in Google Summer of Code 2026. So the reason number one is the universal compatibility. You can run on any OS, right? Anything on web-based. And basically, if you remember Java at the very beginning, they were kind of selling you the dream of code one, execute everywhere. But the reality is that Java, for many reasons, never became that kind of universal platform that they wanted to be. However, the browser and the web technologies that run on that browser have become exactly that. Web is available absolutely everywhere. Every single device, from my smart glasses to my phone, to my laptop, to my desktop PC, all of them have a browser, and all of them can run modern web applications in obviously different flavors. Luckily for us, the LG, the Liquid Galaxy is exactly the same. It can run browsers, and if it can run browsers, we can put our hands to work, and I will show you how very, very quickly. The other aspect of that I love about the web is the rapid prototyping, right? You can change code, refresh, it's going to be there very, very quickly, either if you develop or if you're making changes even in production. So I'm going to be showing you as well NodeMon, which is a very quick project that is an NPM package that will allow you to see the changes that you are making on your code live on the browser as you are coding them. Very, very important. Obviously, the web has one of the richest ecosystems out there, from NPM packages, extreme open source libraries, entire teams at the best companies in the world, Google, Microsoft, and others, Mozilla, working constantly in standardizing the web, in improving the web performance, in improving the web accessibility, improving the web APIs. So there is a massive ecosystem behind it. The web, finally, even though the web is sandbox and has been sandbox on that browser for almost the entire story of the internet, the reality though is that as the browsers have become more and more important, now we have almost transparent access to a lot of the hardware that is underneath the browser. You want the CPU, you got it. You have the memory, you got it. But you want the GPU, you have it as well. You want Bluetooth, you want many things that usually the browsers could not do. Nowadays, there is a web API that allows me to get very low level on the computer that I'm running. And that's very important because we want to do high performance 60 FPS graphics. And in order to do that, we are going to need that acceleration that comes from the hardware. It is extremely easy to deploy. We're going to see that as well. And the beauty of the remote controller that all of the Liquid Galaxy rigs use is that I don't have to install any APKs. I don't have to publish my application anywhere. I just need to publish a website, and I can get a controller for my Liquid Galaxy without going through any of the typical processes or typical deployment of an Android app or a Flutter app, etc., in order to get it done. So the beauty of the Liquid Galaxy projects and of the Google Summer of Code in general is that if you are selected to build a project with us, you are going to be able to build on the shoulders of giants. And I'm going to show you two incredible projects today that use web technologies but there are many, many more. So I invite you that after this, or if you're watching this on a recording, pause the recording right now and go take a look to these two projects, but also to many, many others that use web technologies. One of them is Galaxy Pac-Man from Leo. This Galaxy Pac-Man basically allows you to play a multiplayer version of Pac-Man in 1, 3, 5, 7, however many screens you like, with one player per screen that can combine and have that piece. It has a massive 2D canvas, have these ghosts, has the ability to have controllers on phones, tablets, regardless of what they are, all through the web browser, and it's extremely fun. I have linked the repo on the slide. There are videos in there, and if you go to the Liquid Galaxy channel, of course, you can see the Galaxy Pac-Man running. It is an impressive project, and I recommend you to take a look. And the Galaxy Pac-Man kind of became the pinnacle of 2D gaming or 2D kind of canvas-based projects. And in the same way, it came from other previous projects like Snake, etc. There were other projects before it, but because he had right years of expertise and years of other students that created code, he was able to go much further. And that is the beauty of open source code, right? And is you're going to be able to build your projects on the shoulders of giants. So you can today, GitHub clone this entire thing and take a look on how it was done. So if you want to do something more complicated than the Galaxy Pac-Man in the time that the Google Summer of Code allowed, you likely can, because you are not starting from scratch. And this is very important that you understand as a member of Google Summer of Code. Here, we don't want martyrs. Here, we don't want, heroes that are going to recode the entire web, in a summer. Good developers are lazy developers. So you want to identify what works, identify what you need, identify what has been done, and of course, identify where you can add value, because that's what we're going to focus on doing during that summer that you work together. But do not reinvent the wheel. Use these projects because they are absolutely fantastic. Second project that I wanted to talk about is LG Space Chess. This project was absolutely insane. There was a launch of a microsatellite with a small chess engine, and every couple of hours, I believe, like 2 or 3 times a day, the satellite crossed through these antennas, and we could send a move, and we were playing chess against this satellite that was still orbiting today around the world, and you can play chess against it through that piece. But today we're going to focus on something very important, and is that this project, the Liquid Galaxy Space Chess, actually used Canvas to render the 3D engine, and it has actually several views. It has the chessboard, which is what I'm showing over here, but it has also the Earth and a simulation of the 3D satellite going around the Earth to know exactly where the satellite was at any given point. And both of those things were made with 3JS, and a 3D canvas. So these are the two projects that I have chosen as a reference of a good example of a 2D project in web technologies in the Liquid Galaxy, and a good example of a 3D project on web technologies on the Liquid Galaxy. So what we're going to do now is, I decided these projects are great. However, first, they are already some years old. One is, I believe, from 2021, the other one from 2023. So you have, obviously, new things have happened. And not only that, because they are complicated, right? The Pac-Man logic is complicated. The satellite and the chess, they are complicated. So I wanted to make a very simple, essential project where only the minimal things that you actually need to have an application in the Liquid Galaxy via the web. And once more, I cheated, and you won't be able to launch this as it is on the Liquid Galaxy, because you will need an additional script to launch the Chromium browsers in there. But everything else, so except that script to launch it on the Liquid Galaxy, everything else you can download in your computer today. And I also prepared a viewport hack in order for you to have several windows responsive to whatever size of a screen you have, and you're going to be able to experience a Liquid Galaxy web base directly on your computer at the end of this talk. So the mission of the LG Web Starter Kit is to create a very robust and reusable foundation for you to fork and get started with a web project in Liquid Galaxy. And it's going to feature Node.js and Express. Node.js is the technology on the backend. Express is going to be the HTTPS framework. We're going to have Socket.io, which is our wrapper to WebSockets that is going to work in combination both in the backend and in the front end. We're going to use HTML Canvas, and I'm going to give you two examples, one in 2D, one in 3D. And finally, we're going to use for the 3D one, Three.js to access WebGL in a kind of a little bit of a cleaner and more organized way. But more importantly, we're going to control the cameras that allow us to cut the 3D world in 3, 5, 7 or more windows properly so we can actually access. And instead of having to do a lot of math, with Three.js, it's going to be one line of code to make sure that the frustrums of the camera are aiming to the right things. Architecture-wise, we're going to make an authoritative server. That means that all of the simulation, all of the logic of everything that I'm going to show you today is going to happen on the server side. And we're going to do very stupid clients that only render whatever is there. And this is a good practice in general in the Liquid Galaxy. Sometimes you're going to have to do distributed things. But the reality is that the Liquid Galaxy is a master-slave configuration. Usually everything runs in one computer, and there are slave computers that its only mission is to render the rest of the stuff. And on the web case, we can kind of get that to the extreme, and you're going to see what I mean in a moment here. So what web technologies are going to be in use? I'm going to present you the A team of web technologies that we're going to be having here. As I mentioned, the backend is going to be with Node.js and Express. Node.js is the dream of JavaScript everywhere. I know that a lot of people is allergic to JavaScript. If you are still allergic to JavaScript, I'm sorry to tell you. First, bad luck, because JavaScript is absolutely everywhere. Second, if you hate JavaScript still, it's because you don't know JavaScript yet. So give it a go, because the reality is that once that you dominate JavaScript, there is very little that you cannot do. And usually it's true, there are other languages that are more performant. There are other languages that do better at math and things like that. But the reality is there are very few things that you cannot do with JavaScript today, especially if you know the language. So give it a chance. Because, thanks to Google's Chrome Create engine, you're going to be able to have event-driven and very fast backends running on Node.js. And obviously, right, Node.js comes with an amazing set of packages through the NPM ecosystem and other sources, but obviously NPM works really, really well. You can download, right, thousands of libraries, and two of them are going to be used today, Socket.io and Express, to accelerate the development of it. Express is a minimalist web server. Basically, it's a super lightweight framework that runs on top of Node.js, and it's going to allow you to serve the very little HTML, JavaScript, and CSS that is part of this example. But not only that, because Express is able to kind of synchronize with Socket.io, we're going to also serve the Socket.io library to the client through Express as well as part of this. Routing is super easy on Express, so you can handle web addresses, and when a screen asks for a 2D controller or a 3D controller or the controller itself, it's very easy to route and get and serve the right folders or the right files that you want to serve on that piece. And of course, it does I would say, very good job. It does a normal job for a web server to put a static file serving. So all of our HTML, CSS, 3D models that you want to serve, in GBL or whatever it is, you can serve them as well with Express. So it's a mandatory piece for almost any project that is going to be web. You need that piece. The other technology that we're going to be using, as I mentioned before, is WebSockets. WebSockets is a solution to the traditional kind of web traffic model, which is request response. So I need something, therefore I go to the server, I knock, I negotiate with the server with the scene, the acknowledgement, the scene ACK, and I have that three-way handshake that usually happens right on an HTTP connection. That is in the end a TCP connection. What happens with that? If I am updating something 60 times per second, because I am, having a ball bouncing around a 3D space, and I need to do that at 60 frames per second, me asking to the server and me doing a three-way handshake every time that we are having these conversations is not going to cut it, right? There is no way that I can get performance animations, performance simulations, when all the logic is on the server and I am only rendering whatever the HTTP server gives me. Therefore, I need a way of breaking that model. I need something that is not as slow and not as chatty, right? Because that HTTP connection, it takes 3 messages, right? Exchanging with the client and the server in order to get even that first byte of data. The reality is that, again, we need something much quicker and way less verbose. So the beauty of that is WebSockets. WebSockets is a persistent two-way connection that is going to connect your client, your browser, and your server in this case. And you're going to upgrade your connection from HTTP or HTTPS to WS WebSockets or WSS secure WebSockets on that part. And the beauty is that from now on, you don't pull that data. It's not you going to the server, asking to the server, hey, do you have something new for me? No, now it's the server that is going to tell you, hey, I have something new for you, and nothing, and something, and something, and something, and something, and something, 60 times per second, so you can draw the simulation or the results on the simulation on the screen. However, WebSockets, especially if you use the raw API, have a couple of weaknesses that you can code around. But it's not easy, right, to do reconnections, to do handling delays, handling lost packages in a socket. You can do it, of course, but honestly, someone else already did it very, very well. So if they did it very, very well, what do? We are lazy, we reuse it. Socket.io is a reliability layer for WebSockets. It's a wrapper that goes on top of it, and it will allow you to do things like auto reconnection. Sometimes you will lose that WebSocket connection, so it will do a fallback to that long polling, which is, I'm going to ask you, from time to time, if you are ready to give me more information, which we know is too slow for a simulation to work, but it's useful to have that ability to go when something fails to the basic technology and then be able to know that the WebSockets are back up so you can reconnect to them. And doing that manually takes, a few weeks to code that properly, probably. But thanks to Socket.io and a lot of Google developers and many other open source developers that have contributed over the years to the Socket.io library, you can get all of that done very, very easily. There is also namespace and rooms, which basically you can say who that message is for. And it's very cool because you can create like categories of messages, right? Like very different chats. So this is the settings chat. This is the live upgrades chat. This is the configuration chat. And you send messages that can be heard only by the people that is listening to those namespaces or to those rooms. This is very useful, and I'm going to be showing kind of a mini example of that today, but for complex projects that require synchronization in many ways, that have a lot of devices, like a multiplayer game that is played on the Liquid Galaxy, these namespaces and room becomes super important. The other one is packet buffering, which is, again, what happens, if there is delays on that part. If the delays mean queues, means packages waiting either on the server or on the client going in one direction or the other. So you are going to need, to do those things and to handle those things if you want the proper simulation. Once more, this takes time and some kind of expertise, or some sort of expertise. Sorry. So in order to get to that level, you are gonna need, a little bit of extra code. But once more, why code it yourself? Why reinvent the wheel if you already have it in Socket.io? Okay, let's talk about frontend. The first technology that we're going to use on the front end, and in fact, the first and the last, because we are going to use Canvas in 2 ways, is the raster graphic surface. So basically, Canvas is exactly that, a white canvas where you can draw on top in either a 2D or a 3D context. You have what we call immediate mode rendering, so fire and forget. This is really important because it allows you to draw commands with paint pixels and then discard the object data very, very quickly, and the next frame is a whole new world for you to process. This is very typical if you have done game engines or you know a little bit on how game engines or high fidelity and high frame rates simulations work. This kind of fire and forget method, it is really important, and it is how the GPUs work underneath, and it's what your screen is doing every single time or every single second, hundreds of times, 120, 100, or 240, depending on what you have, maybe 60, 30, 24 if you're looking at the cinema, right? But the reality is that you need that ability to rewrite this canvas, and this fire and forget is very important in order to make these high performant and high FPS simulations that we want to have on the Liquid Galaxy. The beauty of the canvas, like everything else on HTML5, there is a JavaScript API for everything that you're going to do, and you're going to see some of the JavaScript today as part of the conference. It is super high performant because it is hardware accelerated. So you don't see it, but the reality is that Canvas is using WebGL and WebGPU under the hood to give you the best possible performance. However, there is a button here, and it's you have to use it well in order for Canvas to use that. And I'm going to show you one of the tricks that many people kind of does wrong when they start with Canvas, and they are surprised that it's not performing properly on the painting side. And a lot of times is only because of the timing of those draws. And I don't know if you're familiar. I mean, if you're a gamer, probably you're familiar with the concept of VSync. But if not, I'm going to show you a little bit on what VSync is and why it's important to have that in mind when you are using Canvas on the browser for a purpose like real-time simulations or games in a browser. Finally, it's pixel perfect, so you have low-level control of this canvas if you want. 3JS is 3D in the browser. It's going to allow you to kind of model 3D graphics, but in order to access, WebGL, you have to know about shaders. You have to know about a lot of details of how 3D actually works under the hood. The beauty of 3JS is that it's going to give you objects, a scene, cameras, meshes, lights, and you're going to be able to very quickly put together 3D scenes without knowing how 3D actually works under the hood. That level of abstraction is really important, and you will see that if you try to touch WebGL directly, it's not easy, it's not beginner-friendly, to be completely honest. 3JS is both. It's easy and it's super beginner-friendly, and I have seen people do amazing things with 3JS in a matter of a few hours. There is this scenograph system, as I mentioned, is essentially a hierarchy of objects that can be inside other objects that have positions and relative positions to their parents, which allows you to assemble scenes and make animations as well in a very, very easy way, context-aware animations, I would say. It has plenty of advanced features. I mentioned some, like lighting, but it has shadows, it has physics, it has PBR material, which allows you to do realistic materials with reflections, with normals, etc. And it has, of course, the ability to load 3D models in GLTF or in OBJ. So you can, not only put some spheres and some cubes or something like that, like I'm going to do today, you can do many more complex things than those. And once more, it lives on top of the canvas, therefore is hardware accelerated. So you're going to be able to render almost at a native performance, the same as that the video game will render. That's the same thing that is going to happen. You're going to be using if you have a good beefed up GPU, you're going to be able to use that directly in your browser through 3JS, which is absolutely impressive. All right. So a little bit on the architecture of what we're going to build. We're going to have a Node.js server, and the role of the Node.js server is to be the source of truth. It's going to run on port 3000, and it's going to usually run either on its own machine, that could be, outside the Liquid Galaxy, or it could run on the first computer, on the master computer of the Liquid Galaxy. Then you're going to have two more screens on that Liquid Galaxy, right? The screen 2 or screen 3, and maybe screen 1 as well. And those are going to ask to this server for the HTML needed to show whatever they have to show, basically the client that goes in there. Those clients, once that they have the web application that they download, they also are going to give them in the same URL the screen that they represent, a screen 1, a screen 2, a screen 3, a screen 4, 5, 7, whatever it is, or if they are a controller for the Liquid Galaxy. And all of these clients that we are downloading through HTTP, they include some JavaScript, of course, but they include as well the socket.io client on that side. So not only we're going to download the HTTP, the CSS, the images, the JavaScripts, but we're going to be opening WebSocket against that server. So each one of the computers that form the Liquid Galaxy and each one of the controllers that are involved in this process are going to connect through WebSockets against that Node.js. Why? You're going to see why in a second here. So the idea here is that in a closed network, right, you can get this master Node.js server will serve you the web application. Once that web application is served, we're going to throw web connections in order to start to upgrade our HTTP to WS, right, or HTTPS to WSS. We're going to open a WebSocket connection in order to get information directly from the server. This is going to be essentially very small JSONs that include updates of whatever simulation we are seeing on the screen. So the interesting part, let's see if we don't break anything. I'm going to stop sharing my slides for a second here, and we're going to go for the entire screen and show you what I have built in here. All right, so entire screen, screen one. I'm going to need now that somebody confirms. I don't know, Andre, you can confirm, or anyone on Discord can confirm that they can see my screen. Let's see. Let me know if my screen can be seen, please. Okay, I see people typing, so either it's a disaster or it works. Yes, it is visible. Perfect. Fantastic. So in that case, what I'm going to do is I'm going to reload here very quickly.
It works okay,
and I'm going to show you.
Places.
Fantastic. That's great. So what I'm going to show you here is I have opened 4 different browser windows. And in these 4 different browser windows, I am loading only, right, a URL. So if I go in here, you will see that this kind of blue screen, right? I have a screen 1 in here. And look at the address. I have localhost 3000 /2D. And then I have a parameter, a screen 1. If I do the same, sorry on this, I'm going to do the same in here. I have localhost 3000 to the screen 2. Sorry, okay, copy pasted here something in the middle. There we go. So you have the thing, and you can upload, and you're going to see, right, this in real time of what we have as part of this. So, like this. So I can reload, right, and I'm going to be seeing a screen number 2, and then I have a screen number 3 with the same idea. I'm gonna, let me see, do it this way, 2D and screen 3. Okay, so finally, I also have opened over here a controller, which is localhost 3000 /controller. And what I'm doing in here, right, for those that are not following, is this should not happen, okay? These are different screens, and what is going on is that whenever they are close enough together, they seamlessly are rendering a canvas that is much larger than this actually is. So if I start putting here, you know, additional balls in additional colors, let's put some. There we go. Hopefully the FPS is good enough. You will see that I have these balls running all over, right, in this 3D space. But this should not be possible, right? In the sense that these 3 things are different computers. This could be, you know, my phone, my tablet, and this computer. This, in this case, represents the 3 computers that are in the Liquid Galaxy cluster. So what is happening under the hood? We are going to see that very, very quickly. But first, I wanted to show you how it works and what it does. Of course, I have a few fun things like my controller, so I can slow them down almost to a crawl, right? And have this kind of very relaxing type of life, very hypnotic. I love it. I've been, you know, doing this all afternoon today as I was testing. I can do as well the gravity mode, which is or will fall around and they will become just, you know, kind of subjected to gravity. I'm going to liberate them again, and I'm going to add some more, and I'm going to make them quicker. Now, 2D is cool. You know what is cooler than 2 dimensions? 3 dimensions. So I'm going to update here, and I'm going to change on my URL 2D to 3D. And now what I have is a 3D space. All these balls are trapped inside this blue cube. And what I'm doing is I am orbiting the camera. You see how I'm moving the camera side to side in order to see that cube in different perspectives. I can, of course, continue to add more balls as I go. I can change the bounciness speed as I've been doing before, right? Or I can accelerate it a lot. And the coolest thing of this is I can actually zoom in, almost getting my head inside the cube, and go out, right? And see this very, very, very far away. But of course, if I put it enough far away, I'm only using one screen. So I want to see it here. But look at this. This is really important because look at the borders of the blue prism, right? This rectangular prism. Look how they are continuously following, right, that piece. In order to do that, because on the 2D example, right, when I'm doing this, the 2D example is very clear, right? How am I doing this? Because I can, if I have a 2D plane, I can just cut that 2D plane, and I'm going to show you how with code in a second here. But in 3D, it's not easy at all because I have my camera that is kind of having this cone of the area that I can see. So in order to keep those 3 different cameras that are one in a screen 1, one in a screen 2, one in a screen 3, coordinated, right, and with the same huge point on that 3D wall, that's actually harder. There is a lot of math involved in doing that. And the beauty of it is, I don't know the math. Well, I know the math, but you don't need to know the math because I can do it with one line of 3JS if you stay with me just a little bit longer. All right, so this is what we're building. It worked. I'm very happy. The last thing that I wanted to show you on how it worked is how I launched it, right? So basically, what I did here, I'm gonna do a clear. I'm gonna maybe give you a little bit of zoom here. So what I did is I launched it with a screens equals 3. That is environment variable, which are the numbers of screens, and then just I do npm start. If you do npm start without the screens parameter 1, 5, whatever it is, right? You can run it here, but I'm gonna do an example with 2, for instance, which is relatively easy. And if I do it with 2, you see that I am connecting all these clients. Funny enough, 3, 6, 7 lines appeared because I have 3 doing 2D, 3 doing 3D, and 1 client being the remote controller. So I'm controlling who is connected through WebSockets to my server. So now, if I go here and I start reloading, what is going to happen is, of course, the number 3 will be empty because right now I told him only 2 screens. So as you see, right, you can actually simulate this in as little or as long as you, in as little screens or as many screens as you would like. I won't go to do 5, 7, etc. because it's kind of hard to see in one screen, but it is possible if you are patient enough and you want to control them properly. And same thing, if I were to update the 2D view, I would have 2 of them, and you see how the boundaries have been recalculated as part of that space. So funny enough, with this could be a game, this could be a shooter, this could be I don't know, Arkanoid, this could be Pong, this whatever you want to do. And thanks to this way of doing things, and the other thing that is very important, this whole thing, this whole demo, I swear to God, it is actually less than 850 lines. And I swear to God as well, half of them, more or less, have to be comments, okay? I put so many comments in here so you can actually follow what's going on. And you're going to see that it is, you see, physics loop, the optimization, the AI, I have to say, Gemini helped me to put all of these comments for you. The code is mine, the comments are mostly Gemini, but I make sure that all of them are correct and accurate so you can follow the code very, very easily. This is, by the way, one of my favorite use of AI is have AI create a good README and comment, so Victor of the future remembers exactly what happened here. So I used AI to add comments and to make documentation in real time. So I use it here as well for you to have this piece. And you will see that a lot of the simulation, right? For instance, this is how they are bouncing back and forth, how they are bouncing on the E-axis, on the X-axis, right? So I have plenty of these things. So most of the simulation, and again, the green here is comments, right? Most of the simulation happens in about 250 lines. And if you have done before these bouncing things, it's very, very easy. Honestly, it's not complicated. And then if you go to, I don't know, my 2D simulation, again, there is a lot of code, right? And a lot of comments. So the reality is in less than 100 lines, I'm drawing the whole thing without much. And to be honest, most of it is taking care of the offset and things like that I'm going to show you now. But the reality is that drawing this, look at how the balls are drawn, for instance. So if I look in here, the balls are drawn with arc. Arc is, a partial arc. So an entire arc of math pi multiplied by 2. That's a circumference, right? So I can have that piece. So I need, where is the object at? What is the radius? And then I just need to go from 0 to math pi multiplied with 2. And that is an entire circumference. So for every object, go through and just draw it. So if I go in here, let's see actually what the server is telling me. And now after this, we're going to go back to the slides and I'll show you how this actually works on the code. And I have prepared a good summary on this. But let's look. So what I have done is I am sending this 60 frames per second, but I am only logging it 1 time per second on the console because if not, you will go crazy. But what I can do is I'm going to take a look and I'm going to look at the camera. So I have the camera with an X, Y, and Z. I have a list of objects, my 11 balls specifically. So I have here, the color, ID, radius, X, Y, and Z position. On the next one, I have the color, I have an ID for it, I have the radius, and I have the X, Y, and Z position. So what I'm sending is 60 times per second. I am sending this information so I can render that. So the clients know nothing about boundaries, know nothing about physics, know nothing about the controller. The only thing that they do is, this is the list of balls that I want you to draw. This is where they are, and these are the colors. Draw them for the user. So the client knows nothing about the simulation. Everything happens on the server side, and that's the beauty of using this type of tech. All right. So with that said, I'm gonna stop this sharing, and we're gonna go back to my slides now. Let's see. 1 second, please. There we go. Share. All right. So that was the demo. It worked. Nothing broke. So sad. I wanted the risk, So I had a screenshot here in case it broke, but it didn't broke, so we're good. So how is the sausage made? Let's take a look at the code that is underneath this. So the first thing that you need to do with this and with almost any other projects, you want to run npm init -y. You want to create your package JSON, and you're going to install the core duo of almost any web application that is used Node these days, which is Express and Socket.io on top of Node. After that, you're gonna also install, if you want, NodeMon. NodeMon is what I told you before, that I'm making changes on the code and it refreshes automatically. NodeMon allows you to monitor Node software and essentially reload the server as you are going. Very important if you are coding locally. I recommend always to have this as a development install in your package JSON. And if you go to my package.json right now, you're going to be able to do that live in here. And of course, I created 2 folders, the server and the public folder, which is what I'm going to serve to my clients on the other side. Important first kind of tip that is not in all projects. When you go to the Liquid Galaxy repository, some projects won't have this line, and it's very important that you do put it in here because you want to use modern ECMAScript 6 imports. So you want your project to be a module. This will allow you to do proper imports instead of the all require statements, and that changes a lot how easy it is to use the npm infrastructure. So make sure that you add a type module in your package.json. Now, let's talk about the server. So in the server, and obviously I have the code itself is a little bit longer than this, but I have kind of extracted in the slides the minimal lines to comment with you. But obviously there is a little bit more of glue that is needed for everything to work. But look at how little you can actually put together a web server with Express and Node.js. So you're going to import Express, import create server, import server from Express, HTTP, and Socket.io. You're going to set up your app with app equals Express, HTTP server, create server app, couldn't be easier. And then you're going to also create an IO, which is a Socket.io server, which is a WebSocket server with new server. And you're going to, again, because WebSockets upgrade from HTTP to WebSockets, you need to use an existing HTTP server. So that's the 3 lines that will allow you to create your Express app, your HTTP server, and your WebSocket server. You're going to define as well a public static folder. Basically, this is where you're going to be serving the contents from. And finally, you're going to start listening for any demands, right, on that piece. So basically, anything that comes on the port 3000 is going to be interpreted in here. There is routing, right, because I was listening to a /2D, a /3D, a /controller. So in order to do that, you're going to have to filter, right, inside that, and Express.js will give you the tools in order to do that. So minimal Socket.io. Another thing that you can do, and this is something that I don't want to go super deep today on that part, but sometimes depending on your network configuration, the cross-origin request is going to matter quite a bit. It means that who can make requests against my server. And in this case, what I'm doing is origin star. This is obviously the asterisk, sorry. This means that anyone can make requests to my server. Sometimes you want that to be the case. Sometimes for security reasons and for privacy reasons, you don't want that to be the case at all. So you have to be careful on this. But I recommend that when you start, you do it with all open. So you can discard that as an issue. And then, the good security measure would be to close it for anything that is not required to do those pieces. So you can be as open as you want. This is an example, or as close as you need, and as security indicates you. In this type of applications and demos, again, obviously, origin asterisk is the easy solution, but don't go with the easy solution, because there is a reason on why this cross-origin restriction exists, and you want to be aware of those restrictions. Finally, we're going to do .io on, and when a new connection happens, we're going to start listening to some things. So if it's, and this is the channels and the namespaces that we were talking before. If you are doing an update settings, if you are doing a disconnect, so depending on the type of message, you want to do different things with those messages. So on connection, and then socket on whatever name of the channel, and response, right, with whatever it is. And you have this kind of arrow function that come with whatever data the content of the package had in it. What the server is doing is going to take, for each object, is going to do some calculations, right? And it's going to take, okay, so I have my object with an X position, so at the velocity in X, Y, and Z. And then, of course, if I am touching the walls, right, I'm going to have to bounce against them. So if you have done this before, you will realize this is very easy. If you haven't done it before, that's fine. You can learn, but I won't go through the physics process, right, of those bounces in this example. I would go, though, through something important. That is, the server is being called with set interval 1000 divided 60. So if you look here at the bottom of the screen, you have that every 1000 divided by 60, we are going to run this, which is update physics, which we don't know exactly how we are bouncing, etc. And then we're going to do the public state. We're going to construct, we're going to build the JSON structure that I showed you before, that each of the clients were receiving, with my settings, my camera, and my array of objects with their position, right? So as I go through that, remember this, because I'm calling set interval on the server, because the server is not drawing anything. So for the server to keep a 60 frames per second simulation is as easy as call this function 60 times in a second. For the client, though, rendering 60 frames per second, it's different. And I'm going to show you why in a second. So the Socket.io client, the beauty of Socket.io, as I mentioned before, is that it's not only a server-side library, it also includes this automatic Socket.io/Socket.io.js that is going to allow you to connect to that library. So in the client, you're going to do socket is equal to IO. And once more, you're going to do socket on a state update, socket on whatever. So you have the ability to connect to those channels that we were mentioning before. So you don't only need to know the name of the channel, and you're going to be able to receive data directly from them. And of course, you can also emit your own messages. So you want to reset ball or add a new ball, etc. You can send those messages directly through the Socket.io client. Now, it is very important to understand what's happening here. Conceptually, when I'm launching an application with 3 screens, I have a massive field, which is that green square on the back, of 3,240 pixels multiplied by 1920. That is 3 screens of 1,920 per 180, rotated 90 degrees, put together. So when that's happening, it is very easy to understand what do I need to do, right? Because I have a ball that is on 1205.45 on the x-axis. That means that is on the second screen, right? Because it's more than 1080, so it's going to be somewhere here inside the second screen. But if I am only looking, right, at that one window, actually, this is not 1280. This is like 200 and something or 160 something of the second screen. So drawing a lot of stuff in this configuration and understanding what X and Y and Z means inside your configuration, which screen do you need to hit, can become an absolute mess. Unless you know this one trick, and it's translate. So when you are drawing, and this is my draw function, or an abstract of my draw, an extract, sorry, of my draw function, you're gonna save the state of whatever you were doing on your context. You're gonna translate via the global offset. And the global offset is how many times 180 you are in. So if you are in the first screen, the global offset is 0. If you're in the second one, the global offset is 180, minus 180 in this case. And you are in the third screen, it is minus 180 multiplied by 2. So once you have that concept clear, basically what you're doing with context translate is move all of the orders of drawing new stuff, you are moving them, those pixels back on that part. So it's like moving, the green square, right? Coming over here on the green square and moving it back, essentially, so you can pull it out. And now you are drawing directly in that second square only, which means that in order to draw my circles, I need to know nothing about all of that because I already moved the offset to make that happen. So because of this offset capability of translating the entire canvas back into one direction, I can very easily draw in 2D. 3D is harder, as I mentioned before, but we will explain that in a second. The last trick that is on this example that you need to know if you want to do good Liquid Galaxy web applications is request animation frame. I mentioned before that set interval works perfectly fine on the server because the server is not painting anything. However, if you try to do the same thing, set interval on the browser, and you try to call the draw function 60 times per second, you may find yourself with very weird animations. And what is going to happen is that sometimes the animation will slow down, sometimes it will accelerate, sometimes it will be choppy, sometimes it will be smooth. Why? Because set interval is not doing 3 very important things. First, set interval is not aware of desync. Desync is how quickly your screen can actually draw. And the reality is that if you want to do, 60 frames per second, but your screen can only do 30, it makes no sense for your client to make calculations and try to draw, right, 60 times per second, because your screen can only show as many as it can show, which is 30 per second. Maybe it can do 20, right, 120, sorry. So in that case, you need to do twice the work in order to get that. So what request animation frame does is it calls your draw function synchronized with the refresh rate of your screen. And that matters a lot because it is the difference between smooth animations or very choppy ones. Another aspect of set interval is that power friendly. So basically, you won't loop unless you are looking. You won't loop if there is an issue of RAM being, for instance, overloaded on your computer, etc. So set interval is not smart at all. Set interval will be called no matter what. Request animation frame, though, it will only be called in sync with that screen refresh rate. It will only be, this will guarantee smooth animations, and it's power friendly because of the design of the API. Now, I promised you before, I wanted to go through the 3D world as well, right? So as I mentioned, right, the conceptually speaking is the same thing, but imagine that you take, 3 cameras, 3 phones, and you are trying to kind of put the phones perfectly distant, aiming at the landscape before, and you want, whenever this camera, that is kind of doing a cone on all directions, right? Whenever this camera finishes, right, wherever the line of my camera is, I want to put the next camera separated enough so where my picture of this phone finishes, it starts the other one. So in order to do that, right, and for that line of separation to be perfect at all times, it's super hard to do. A lot of math, unless you're using the right thing. And it's, okay, so there is something called asymmetric projection matrices. It is as horrible as it sounds. It's trigonometry. It's not super hard or anything like that. You can do it, and you are all smart, probably computer science students. You can do this, okay? It's not that hard. However, you know what is not that hard either? Camera dot set view offset. One line, and all of that math goes away. So what you have is, I am, my full width is 3240. My full height is 1920. My width is 180. So I'm going to do, and I have my screen ID, right? Let's say a screen number 1. So 1 minus 1 is 0. This is 0. So 2 minus 1 is 1. That is 180. So I give that. And now that complicated math is just a translate with 2 coordinates. Camera set view offset, full width, full height, the X and the 0, width and height of whatever I am aiming at, and that's done. 3JS will do all of the math for you, and you can place as many cameras as a computer you have on the Liquid Galaxy cluster and be able to very quickly make those points. It is really, really, really easy to do. Now, the last thing that you need to know is, I told you before, I lied, right? Was this a Liquid Galaxy project? I saw no Liquid Galaxy at all, right? I saw 3 browser windows and another one to use as a controller. So if you want to launch this on the Liquid Galaxy, you will need to listen to one of the many other mentors that will have talks during these streamings, and someone will show you how to, control the Liquid Galaxy with bash scripts and etc. So what you need to know is that the only thing, whenever everyone is fighting the network and the Liquid Galaxy APIs and is doing shell scripts, you're gonna do one line on your shell script, and it's launching Chrome with 4 flags: a start full screen, for obvious reasons; autoplay policy, no user gesture required. This means that you don't require any clicks or anything like that on the browser to start playing audio, video, or whatever you have on the canvas. You want to make sure that it's a new window, so it doesn't open tabs, when you launch new ones. And you want to calculate, in case that you cannot place it, right? You want to calculate the window position. So you want to say, I want it on 0, 0, and I want it to be whatever size that Liquid Galaxy cluster screen actually is. If you launch with these 4 things, and again, other mentors will show you proper Liquid Galaxy projects with bash scripts and how to connect to the computers and the master-slave architecture. If you do web, we don't care. That's great, okay? We care about only these 4 flags, and everything else is gonna work. All right, that was quite a bit. It's been almost 45, 50 minutes since I started this piece. I wanted to tell you why am I so passionate about web technologies and what you can do with them on a setup like the Liquid Galaxy. If you like what you saw, make sure to go. I'm going to link it for you now. 1 second. I'm going to link the repository. So go start it, give me a start on GitHub, fork it, etc. Make sure to go there and start playing around with it, because it is, I promise, as easy as it sounds. With this said, I'm going to shut up. I'm going to take a breather for a second. And I'm going to take any questions that you may have. In the meantime, if you don't have them, you can find me as well on Twitter, at Victor Sanchez. I hope Andreu and everyone that was following, that you liked what you saw.
Totally amazing.
Awesome. Thank you, Andreu.
Contributors are totally amazed, because I'm pretty sure most of them haven't seen as a good live demos ever.
That's good.
So
it worked.
Yeah, it worked. Before they start, we have a question. Let me go back. Jean, at scale, how do you compare SSS versus WebSockets in terms of connection management and resource usage?
So the server-side events, right, which is exactly what Jim was commenting here. Server-side events have another purpose, right? And server-side events are not meant to have the same throughput that you have on a WebSocket. Server-side events are also try to solve the same problem, right? In the sense that you don't want to do always the, hey server, do you have something for me? Hey server, do you have something for me? Server-side events are connections that are started on the server side, but are meant to be a one-time thing that can happen many times, right? But it's supposed to be its own thing on every one of these events. WebSockets are different. WebSockets are a persistent connection between client and server that is meant to be the duplex and super low latency. So in order, again, server-side events are useful, right? But are not what I would use at all for this thing. Because on server-side events, is kind of, you have the problem on reverse, right? Usually you have the client asking the server, now you have the server pushing to the client. But the reality is you need both, right? That's the duplex aspect of it. Why do you need both? Because you have things like the controller, right? So server-side events could work for really low FPS animations if you only have the screens of the Liquid Galaxy. But the reality is that because it's going to be super high FPS, because you want the Liquid Galaxy to look amazing, but also there is interaction, right? You could have a controller on that piece. So WebSockets cover way more the use case than server-side event. But excellent question, Jean, on that. And yeah, that's another of the very cool technologies that you have on the web arsenal. But for this, definitely the right technology is WebSocket.
Talking about other questions, uh, you were mentioning during your presentation, talking about mostly about 3 screens. At the end, you remember that you can change the setup. So Deepen is,
Mhm.
I was curious about asking if we can run the Liquid Galaxy on bigger displays, such as Times Square billboards or Burj Khalifa display. Let's let me say something. Okay, Deepen. Think about that the Liquid Galaxy, the idea still is that every screen we have is full resolution, whatever resolution you use, usually full HD. Maybe it can be 4K. So when you talk about one single screen, even if it's a billboard, you say there will be the same resolution. So the thing about the Liquid Galaxy is you add many different screens and then you add the resolution. So, for example, our most typical 5-7 screen systems are 1080 by 5, that's 5000 pixels, but 1920 pixels. So a screen will be enlarged or not, but has the resolution. The Liquid Galaxy has lots more resolution because you add other screens. Is that right, Victor?
Yep. And the reality is that the answer to that question is as long as you have a computer behind each one of the sections, you can do this. And I have been showing you one line, right? Basically one row of screens. But you could do this on 2 dimensions as well, right? You could have rows and columns, and it will be the same idea. I was only translating on one axis, but you could translate that on more than one axis. So you could have this for as many as you like. Obviously, though, you are going to start hitting interesting limitations when you do this, and is how many. There's something that I haven't done, right? But I can break my example, and I invite you to go and break it. See how many balls do you have to put in order to break my example and start to break my physics method that is very basic in order to make those collisions. So as you grow, right, optimizations are going to start to become a problem. Are going to start to become a problem for web technologies or for any technology that you put in there, including Google Earth or whatever it is. So can you do this on much larger screens? Definitely yes. Can you do this on much larger screens with web? Definitely yes. Is going to require so much smart engineering to scale this up? Definitely yes.
Well,
So it's going to require
also,
a
next
little
to
bit of
this is
extra. Yeah.
the kind of demonstrations you did uh, really do not need too much GPU. I mean, even you have dozens of balls bouncing around. I mean, it is not needed. I mean, people can think we need a 50 whatever RTX to run this. No, no, because
No, the
also
reality is
on the
that the what is interesting and what I invite our massive users to do is to break my example. And in order to break my example, you will realize very quickly that what breaks is not the browser. What breaks is Node.js on the backend, because the backend is iterating through spoiler alert, tens of thousands of balls. But at some point you're gonna break it, right? And when you break it, what's gonna happen is not that the browser cannot render it, right? What happens is that the server can no longer properly simulate, because when you have so many balls, right, as part of that, you cannot calculate all of the balls in the absolute time that you need on that 1000 divided by 60, right? That's 60 frames per second can no longer happen on the server. And when that happens, you need to start putting more code on the server. You need threads, parallelization, you need smarter ways of calculating these balls. For instance, if the ball has not collided with anything, I can interpolate and assume that the ball is continuing, so I don't update it. I can start kind of doing tricks on that. But I've done none of that on this example. Therefore, if you want to, you will break it. And the reason is why,
break the code,
but,
Victor.
but funny enough, you will break the backend, not the browser, which is awesome.
So another question
Which
is
awesome.
for students, for contributors, to remember that usually we ask for your projects to be able to handle multiple screens in a number of in part. I mean, 3, 5, 7, whatever. But the usual typical screen we have is 5 or 7. Sometimes we have 3. And then in the real world, there are many Liquid Galaxies, and they can have till a couple hundred screens, many. And let me add another questions before we go to the other questions. Is remember that the typically a Liquid Galaxy rig hardware is low specs. It's low specs because we are not putting an RTX wherever super last minute VGA from NVIDIA. No, we use very plain because to run Google Earth or to run this kind of simple web thing with web application is not needed a large GPU in any way. What do you want to show, Victor?
No, nothing. I just, I was giving a nice background for the for the Q&A.
It's okay. Let's go for another question. Depends size. It was curious about asking if you can run the Liquid Galaxy on big. No, this is the one. Then Mosan, does the Socket.io works the same way as our data warehouses, like nodes for work for big data?
So the answer is no, right? Obviously, if you go to very large warehouses and data infrastructure, they will work similarly. But if you want to have these very large data warehouses, right? Like if you go with something where, I don't know, Firebase, right? Firebase uses WebSockets underneath, but the reality is that Firebase has millions, right, of concurrent users at any given time, sending hundreds of millions, if not billions of messages through that piece. So do they work conceptually in the same way? Absolutely, yes. However, running Socket.io over more than one server, because the reality is that you need more than one piece of hardware, right, running on that metal. So running a cluster of Socket.ios, that's harder because it requires machine-to-machine on the server. So basically, if Andreu is connected on one server through a WebSocket and I'm on another, those two web servers, now they need to talk to each other. Very similar to how the cell network works, right? When you are on your phone and you are on an antenna, and then you negotiate the change from one antenna to the next, the same thing is going to happen when you scale this on the cloud. So does Socket.io work in very large infrastructures? Yes. Do WebSockets are used in very large infrastructure? Absolutely yes. However, there is a lot of code on the backend destined to make this kind of machine-to-machine communications and these clusters to work seamlessly for the final user. So is it exactly the same? No. It is the same technology? Absolutely yes.
Okay. Avi says, what will be the recommended structure to extend this starter kit into a fully production-ready LG application?
It is a very good question. The answer is that it's going to depend a lot on your project, right? So the reality here is that I did the minimum viable product, right? This is the minimum backend, the minimum frontend to showcase 2D and 3D in a kind of very silly way, right? To put it that way. So what I would do on this is learn the fundamentals, right? Understand what the technologies are doing, understand how they are being rendered, and then put it to the test. And what you will find is, my bet is that you will find three things that are going to break. Number one is probably your simulation is going to be more complicated than the few bouncing balls. So you're going to have to start thinking on how to simulate at 60 FPS, or even if you need 60 FPS, because maybe you can draw 60 FPS, but only think about 30 FPS on the server, but still draw it smoothly, interpolating and things like that. So simulation is going to get more complicated. Rendering is going to get more complicated because right now I am doing very basic stuff in these demos. And the final thing that will get more complicated is control. Right now, I am applying very few controls in here, right? I can add bolts, I can change the bounciness, I can change the zoom, etc. But I'm doing relatively little in this example. But when you have a lot of controllers, especially when you're doing something with 8, 10, 12, 100 players, right? You have a lot of things that go on those controllers. And one thing that I really love is the concept of how to make a multiplayer game fair. So something that will happen when you are, let's say, with your phone connected via 5G or via your computer through an Ethernet cable is that my WebSockets are always consistently going to arrive quicker to the server than someone on a very bad connection. Therefore, that game is not fair because my actions arrive way quicker to the server. How do I make that game fair? It's a massive challenge. So there are a lot of things that get complicated, right, when you go outside of the example. But the example gives you kind of a super clean, less than 1,000 lines of code. It's, again, 849 with 200 of comments. So it's very, very little, but you can start doing really complicated things on top of that. But of course, I didn't solve every project of World Summer of Code 2026. This is just the start. Yeah.
Sorry, Victor, I want to say hello because I'm seeing that our colleague Andrew from Australia is just starting to write something on the streaming, and I want to say hello to our old mentor, Avsky.
Good to have you.
Yeah. So the other question was, could I please give the notes on the PDF? Mentor Victor, this is an explanation. I don't know. What I can say is that
I'm happy to extract the presentation on a PDF and send it to you. Yeah.
But actually, this is on YouTube. We are streaming at the same time, so you can review the streaming video, and hopefully today we are having good sound and good everything. Victor, when you were making your presentation, I just leave everything here and go to my big TV on the living room and check everything seems to be okay.
Nice. So.
What else? Also, I want to give a tip to the guys. So we've been doing that stuff of Node.js since the very beginning, Web Canvas. But when you say the word Arkanoid 3D, I like this idea. Let's call it another way because Arkanoid
it's funny because Andreu, I'm gonna confess that this example before this was Arkanoid 3D. Okay. So I made Arkanoid 3D. And then I throw it away. And the reason why I throw it away is because I said, this is a great project for a student. I cannot publish this. So I stopped doing
and
it.
And also because it's registered. It's a trademark. So instead of calling Arkanoid, let's call it Ilginoid, for example, whatever. And then a tip, students, contributors, maybe you can go for it.
Okay, so Alfsky just published a super important message because he said, we have recently started switching away from WebSockets to WebRTC data channels for some of our WebGL apps on Liquid Galaxy. It supports native multicast between clients, so the latency is reduced, whereas WebSockets is always client to server. So there are lots of overlapping TCP chats. All right, so this is absolutely true, okay? I told you that WebSockets was the solution to polling and long polling on HTTP. But as Alfsky is very well saying here on the chat, sometimes even sockets are not enough. And when even sockets are not enough, WebRTC, the same WebRTC that allows you to have video and audio through your browser, that is what Zoom, Google Meet, and all of those web-based chat systems use on the browser, they have a little sister that nobody talks about, but Alfsky knows, and I know as well, it's WebRTC data channels, which allows you to bound in those live data channels any type of information. Basically, you can do signaling, which is usually what the data channels are used for in video and audio, is for signaling of the video and audio requirements of the protocols, like the speed that they're going to be sending those scenes, the NAT configuration, the IC candidates, and many other things that can be sent. They can be sent in many ways, and sometimes it's HTTP, sometimes it's WebSockets, sometimes it's data channel. My previous company, Mashme, we did these massive video walls, and in those massive video walls, we had to synchronize a lot of information. So much information that WebSockets were not enough, and we were indeed using data channels. So, is data channels for you as a student? It's likely that you can solve it with WebSockets, and WebSockets has some advantages. They are very easy to set up. Even when they fail, they are easier to reconnect. However, depending on the amount of data and depending on your latency requirements, WebSockets can be even not enough. As happened with polling and long polling, WebSockets could be not enough. And when they are not enough, you have the our smart contributor here, Alfsky, and myself, or a lot of the mentors in the Liquid Galaxy, can help you to get to the next level. And the next level is indeed data channels.
Okay.
Thank you for that.
Okay, so I think there are no more questions, and we are 1 and plus hour on the streaming, so we have to stop now. Thank you very much, Victor, for starting the training for this session. I am truly sure that students, contributors have enjoyed a lot with your plenty of bouncing balls screen 3D one.
I'm trying to break it, but it's gonna. I won't be able to break it in time.
It's not breaking.
It's not breaking.
Thank you, Tues Suman. Let's wait for Andrew that is writing something. He's giving us a PGS library.
Yep.
And let's wait. Ariane is also writing. Yes, it happens at the end of the streaming. People always want to ask something.
This is now I have to finish, right? Now that he's sharing Peer.js, the other aspect that is very important, right, is the WebSockets are always client to server, as he was mentioning. The difference with WebRTC is that you can do peer-to-peer between browsers or peer-to-peer between server and browser, but everyone is the same. Everyone is just another peer on the network, and that has as well another advantages. But Andreu, you're gonna have to, if you want me to talk about WebRTC, you have to invite me again, and I will be super happy to talk about WebRTC another day.
We will talk about this. Okay.
Awesome.
I don't want to spend more of your time, but thank you very much for the offer, and we will think about it. Thanks for the session, Deb. I'm thrilled how the Saho brought with the thank you, Stephen. Okay, so we are going to close. Thank you very much, Victor, and thank you, community. Let's hope you are getting something and break Victor's code. That's the way. That's the code.
Yeah, okay. Go for it.
Thank you.
Thank you all. Have a good one. Bye bye.
Bye bye.
Screens, living in the grand spatial dream, visualize just what we mean. Innovation shaping our fate, together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvels stand